Hi, good morning, and thank you for joining me in my shop. And today is June 6th, and I ended the last video concluding that a couple of tubes maybe are so weak that they're affecting the radio. You know, that doesn't add up with all the observations and things that have happened, because tubes don't get weak suddenly. But nevertheless, I'm going to replace those two tubes, and the first thing I have to do is I got to scare up some replacements. I didn't bother doing it yesterday, so I'm going to stop and hunt down some replacements. Two 6F5s. Have I got them? Well, hi, good morning, and thank you for joining me in my shop. And today is June 6th, and I ended the last video concluding that a couple of tubes maybe are so weak that they're affecting the radio. You know, that doesn't add up with all the observations and things that have happened, because tubes don't get weak suddenly. But nevertheless, I'm going to replace those two tubes, and the first thing I have to do is I got to scare up some replacements. I didn't bother doing it yesterday, so I'm going to stop and hunt down some replacements. Two 6F5s. Have I got them? So I tested the two original tubes in this tube tester. That's one of the originals right here. I'm going to test it again because both tubes tested low in a radio that once was working quite well. I don't know, there's just so many things not quite adding up here. My antenna are wiggling and saying something's not quite right. So let's just double check these settings very quickly. 2037, everything's good. Okay. For shorts, just in case the tube shorted overnight. How could that happen? Here we go. Right, and this tube, according to this tube tester, if the tube tester doesn't show 1,000, it's time to change the tube. So this is half of the minimum rating, according to this tester. I'm having my doubts. Now I don't want to mix these up, so I'll put the radio. 6F5. This one's going to make it. Over, so this one is in the good range for sure. Okay, so that sort of double checks the tube tester itself. Now I'm going to set this one over here. Let's see if I've got another one. 6F5. Biting my tongue here to not talk about the situation between the United States and Canada. Oh, I just spoke about it. It may change dramatically in the next day or two, so not worth talking about. Here we go. She's a winner. Okay, so I've got two tubes testing good, as opposed to the originals, which were testing bad. Okay. Let me put these tubes in. We're going to run the radio and see if it's all better now. Situation is I can't get anything done with this guy here, so I'm going to use the ping pong ball, which I forgot about, which came from this radio, and I'm going to toss it down the hall here, and this cat is going to go crazy. I bet you his brother's going to show up from who knows where. Okay, there it is. The ping pong hall. Are you ready, Bert? I have the ping pong ball. Here it goes. Don't bring it back in. No, don't bring it back in. There he goes. Okay, that should keep him occupied. That should keep him occupied for a few minutes anyway. Long enough that we can test this radio and find out. was it weak tubes at the front there. Okay, so switch is off. Dim bulbs on. We have the speaker plugged in. I have the antenna connected. I have both leads from the antenna connected. I believe in the loop arrangement. I think. Hey, could that be part of the problem? Here we go. Dim bulbs. Go on over here and have a look at those dim bulbs there. There they go. Okay, all is normal on the dim bulb front.
There are some that are just plain fun.
Yes.
Like watching the most powerful man in the world, the richest man in the world, just like sniping each other was just, it was impressive.
Yeah.
Yeah.
And again, I think, listen, they both kind of built, how would I put it? They both kind of built their brand on disruption. They're both disruptors. So when the disruptors disrupt each other's lives.
Well, but that's what you and I were talking about earlier.
That's
which
not true.
I genuinely think
Trump's not a disruptor, although he's disrupting everything. Trump's a bankrupter. Yeah. And Musk is a builder, even if you don't like him. He's a weird guy in that, but he makes things happen. Trump gets a hold of happening things and brings them down. I mean, that's been his whole life. Uh-oh, don't talk about that stuff, Jim. Did somebody turn a radio on here? What happened?
Trump wants to disrupt Musk financially. That's probably pretty obvious.
Okay, on to something else here. I'll get a copyright hit if I leave that on. Okay, so we're at the far end of the band. So this is actually very good reception. This is a Buffalo station where they were talking about Trump. No, I'm not sure now.
At 9 o'clock, I'm Dave Bradley. One person has been found dead and what's left of a home damaged by fire in Scarborough this morning.
So it's Canadian. Scarborough is part of Toronto.
Quality does look a little bit poorer than normal.
Wildfire smoke is blanketing southern Ontario with a haze. Reduced air quality could affect some people.
Take your pick of music genres in the city this weekend. Oh, I see.
All the time. Terrible.
Sounds like fried eggs. Good morning. It's 9 o'clock. News time on Zoomer Radio. We're at 17 Celsius, 60
This is
degrees
7:40.
Fahrenheit. Today's high 24 with a mix of sun and clouds. There's also an air quality alert for...
Yes, Smokey. So the volume is still
related.
like I'm sure before we were getting loud volume here. Now you're just barely hearing it. And well, anyway, we're going to carry on just as it is because it is working. And as I mentioned before, the volume control is the ultimate repair function in the radio. If the radio's weak, you just turn the volume up a bit. There you go. I think what we're ready to do now is start checking the alignment. And the first stage in doing that is to check the intermediate frequency stage alignment. And I'm going to start explaining a little bit about how these radios work for me to do that. So I'm going to set things up to do the alignment, but not much to set up, frankly. Get my cup of coffee going. I'll give a little description of how the radio works, a very, very simple, high overview description of how a radio like this works. And I'll show you what we're zooming in on to try to align, which really means tune it up properly. There's some internal tuning adjustments in these radios, factory settings if you like, that are usually done once in the life of a radio like this, but this thing's on its 4th life here, so it needs an alignment. Maybe. We will see. Okay, let's take a look at the schematic here, and I'll kind of point out what it is I'm doing and how these circuits are supposed to work. This is the heart of a super heterodyne radio that we're looking at here. Okay, so to to make some sense of this, since you may not be familiar with radios at all, you certainly know there's an antenna that's getting a signal coming to the radio. And then you know there's a speaker producing sound. What exactly is going on in between may be a bit of a mystery. And your early radios were very simple. They just amplified the antenna signal until it was strong enough to be detected. And that means it's turned into audio, and then it would be sent either to headphones or through some more tubes to make it strong enough to drive a speaker. So basically, antenna, amplify, turn it into audio, amplify out the speaker. The problem with that is you needed multiple stages to amplify the signal, and each stage had to be tuned. So each stage had its own tuning knob. So these old radios from the 1920s, you'd find 2 or 3 tuning knobs. You had to tune here, and then tune here, and then tune here, and get them all tuned right, or the signal couldn't come through. There's a big hassle in operating radios. So as soon as somebody figured out how to do it with one knob, which is what we're all familiar with. All our lives we've had radios with just one tuning knob. In fact, after 1930, pretty much every radio had one tuning knob because of a trick called super heterodyne. Super means above hearing, so what's happening, you can't really hear this. Heterodyne means to mix things together. It so happens if you mix 2 signals together correctly, you can get those 2 signals coming out of something along with 2 more signals. You can get the sum of the 2 original and the difference between the 2 original signals. You get 4 signals coming out. So you put 2 signals into something, get 4 signals coming out. That's happening in the mixer tube. In this radio, this is the mixer tube. Now they're calling it first detector. That's kind of a British way of looking at it, or a European way, or somebody else's way. Normally we call this a mixer tube here. And it's mixing 2 signals. What 2 signals? Signal from the antenna, which is what you're going to be listening to ultimately, and another signal developed inside the radio, apart from everything. And that's taking place down here, with these coils and capacitors and this oscillator amplifier here. You need an amplifier to make a continuous oscillation. So the signal from here and the signal from the antenna are stuck into this tube. The 2 signals go in and 4 signals come out. The 2 originals, so the antenna signal and the local oscillator signal, they come out, and 2 more signals. The sum of the antenna signal and the oscillator signal and the difference. So if you subtract the 2 signals, you get a frequency difference. That frequency exists and is coming out of this tube. It's just the way it works. This is extremely handy. When you tune the radio, you're not really tuning much up here. A little bit, but nothing of real major consequence. You're tuning this oscillator. You're changing the frequency of the oscillator and changing the frequency that you're mixing in with the antenna. Now this is where it gets a little hard to grasp. The rest of the radio, or not the rest of it, but yeah, I guess you could say the rest of the radio part of the radio, that's this part here, is tuned to one frequency, just one frequency. It happens to be 455 kilohertz. That's below the AM radio band. The only thing that can go, the only signal that can go through this radio here is a 455 kilohertz signal. Nothing else goes through. So you use the variable local oscillator frequency to mix against the antenna frequency to generate a difference frequency of 455 kilohertz. As you turn the dial on the front of the radio and this frequency changes, the sensation you get is you're sweeping across the AM band. What's really happening is you're mixing this varying local frequency, local oscillator frequency, with the signals coming in on the antenna. All of them, all at once, they're all being mixed, but only one will be exactly right to mix with this and get a difference of 455. Now if you tune between stations, you're listening to the noise between stations. So even if there isn't an incoming signal, this mixer thing is still taking place against the noise inside the radio. the benefit of this is one knob to tune this. You're usually tuning something over in here too, but it's not quite as critical. It's important, but it's not the same as this. So basically you're tuning this oscillator and creating a signal at 455 kilohertz that'll shoot through the rest of the radio. They call this part the intermediate frequency stage because it's an intermediate frequency between the antenna frequencies and the audio frequencies coming out. Or you could say it's intermediate because it's in the middle of the radio. So as the signal travels through, for a while it's in these stages. These are intermediate stages in the radio. Okay, so now we know we've mixed the signal here with the signal there, and we've got a 455 coming through here. These transformers here are tuned transformers, and they are tuned to the 455. This is where the tuning takes place in the intermediate frequency stages. This is what we want to make sure is tuned correctly. So logically, if you have a signal coming in that you've tuned with a local oscillator, so you're hearing a signal coming out, you should have 455 kilohertz traveling through here. Now what can happen is these things are tuned coils. They can drift. And over a long period of time they may drift away from 455. So this one may be 450 and this one may be 460, and you can kind of imagine how the signal would have trouble getting through here. Now what if these are both tuned to, let's say, 440? Maybe somebody tuned this radio without instruments. Well, if you tune this to 440, what will happen is the radio will still work, but the dial won't be correct anymore. The pointer will not point in the right place. Or what the pointer is pointing at won't be the correct frequency anymore. So it's very important to get these returned to the proper frequency and peaked up so they're aligned, so they're on the same frequency, 455 kilohertz. How do I know it's 455 kilohertz? It almost always is in these radios. Not always, but almost always. And I saw it in the manual anyway, because I kept my eyes open for it. We'll find it. It'll be stated somewhere in the alignment instructions. So these transformers are tuned by moving a slug up and down through the coil. That's what this indicates here. This is indicating a variable slug in these coils. You can see there's 4 of them to adjust. The actual way they work in the radio is one is adjusted from the top, and the other one you have to go underneath the chassis and adjust it from below. That's just the way they operate. These coils are not physically the way you see them here in the diagram. They're one above the other, in fact. And so there's a slug in one and a slug in the other. And you can move the upper slug with the top, and you can move the lower slug with the bottom. The upper slug is usually the secondary, the lower slug's the primary, but you never know for sure. That's what we're going to be doing. Okay, now to do this correctly, how do I know it's 455 through here? So what I'm going to do is I'm going to feed a controlled signal from a signal generator into the radio at exactly 455 kilohertz. I'm going to feed it into the grid in right here. It's going to come out, go through this transformer. I'm going to measure the strength of it. A couple ways to do that, but I'll measure the strength of the output from here and then adjust these coils and try to make it maximum at 455. So that's what's going on here. That's I'm sort of focused just on the middle here. I'm not explaining what's going on with the detector. I sort of loosely explain the mixer. The mixer here. Yeah. Okay. Let's do it. Oh, we got to read the instructions. That would be a good idea. I think we can find them down here somewhere. Can we not? Alignment. Oh my gosh! Look at all the writing. So I'm going to, so it has a table here with the basic instructions. This is what I'll be following. But I better read through here because the engineer's taken time to write an awful lot. I wonder what he has to tell me. So I'm going to read all this before we do anything. So the instructions there, number 1, number 2, involve injecting the signal into the grid of 2 tubes, which I could do. Grids are easy to get at. There's grid caps on these tubes, so just make the connection to the grid cap. But a lot of these radios that are working well and are relatively well aligned, you can just jam the signal into the antenna and let it roar through the radio. It'll make its way to the IF and show up. And what signal am I talking about? I'm talking about the signal coming out of the signal generator here. So the signal generator is connected where the antenna was. Right now we're going to try this. I'm going to set this to 455. Turn up the radio here. You hear nothing right now, which is... expect to hear a little bit, but anyway, we hear nothing in terms of noise in that. I see my meter's pinned here. This is not good. Okay. So there's 1,000 hertz signal, a tone being transmitted by this at this frequency here, but it needs to be 455, and we should hear it come out of the radio. Depends if I have this set strong enough. This is the strength setting. It's not so strong. So let's go by 455 and see if we hear something. So I'm hearing it here at 437. I'm going to jack it up here a little bit. Okay, the signal's now 10 times as strong, so you hear it quite clearly now. Once again, I'll tune up and down. I'll go down quite a ways and go up quite a ways and see if we hear it anywhere other than right here. So now that may be a tuning effect. Let me tune the radio. Tune. Yeah. So I won't go into why that happened, but it's nothing wrong with the radio at all. Go back up. The IF, instead of being tuned to 455, is tuned to 437. But it could be that it's, you know, there's 4 things here to line up, to get lined up like that. And it could be they're like this. And the result is 437. Plus, if you notice, when I tuned the radio, there was a very, very broad tuning range. I turned the knob a lot, and the station slowly come in and slowly go out instead of being sharp. Could be because of all this stuff. Let's go up and see if there's anything up above. No, that's normal. If there was something there, I'd be scratching my head. So the objective of the game now is to retune these transformers so the peak occurs at 455 and not at 437. Okay, we would normally start on the second transformer, the one that's closer to the speaker. Doesn't really matter. In this case, because the radio's operating, it doesn't really matter that much. Let's see if I can find a good tool here for this. Okay, action's down here now. Oh, I didn't hook up the meter. Whoops. Forgot to hook up my meter. I gotta stop and do that. Or do I actually have to stop? Yeah, I have to sort it out on a schematic where to connect it. Oh, let me turn this down here. Okay. So right here it says cathode ray oscillograph connections, and it's pointing here to this point. There's got to be an easier place to connect it up. Now I'm not going to use a oscilloscope just yet, or oscillograph as they call it. I'm going to use a voltmeter on this location. Now the reason they're saying cathode ray oscillograph is because they know the input impedance is going to be high. If you have an oscilloscope, it's going to be a megohm or much higher yet. If you try a voltmeter, as far as the engineers knew who did this, a guy like me would have a crappy meter available. I wouldn't have a nice bench like what I have here, because we're thinking back in the 40s. And we'll pull out this clunky, ugly meter and hook it up, and just it would not work properly because the meter draws too much current. Old meters draw current from the circuit they're testing and disturb the circuit. My vacuum tube voltmeter here is fine for this. So, but this connection's hard to get to. It's between R5 and R4. Why would they pick that between R5 and R4? Let's look at the schematic here. Where they're suggesting is on the output of the detector right in here, R5. Here's R5 and R4. This is the output down in here, and there's going to be a DC voltage sitting here. This might be where you can get it without disturbing anything. You could also pick it off here. This is the same spot basically, just on the other side of this resistor. So anywhere in here you're going to pick up a DC voltage that's varying with the strength of the signal coming through. That's what I'm after, the AVC voltage. So it could be, here's the AVC capacitor. It could be anywhere. Best place to connect though would be on this side of this big resistor to stay away from disturbing the grids. And there's some current available, and I'm going to follow their instructions. I'm trying to remember where this point is now in the radio, but this is where I'm going to connect my voltmeter here. Okay, well, I've got this diagram down here to show me where R4 and R5 are. Where'd they go? Here they are. Okay, so I make this connection here. I'll attach a capacitor. No, I'm not going to do it there. That's awkward. A really good place to pick them off often is the top of the volume control. Well, this volume control, it's blocked by a capacitor, so that wouldn't work. We're going to have to go here. I got to find this spot. Shielded cable to a capacitor. Right, Jim. You don't have to go hunting. It's R. What? Hang on. Confused myself here. R4 and R5. R4 and R5. This must be a unused pin right here. Well, let's see if I can find this in the radio. R4, R5. Okay, I have my meter connected this time around, and we want to put the table up here. Right. Just bear with me a second here. I kind of forgot to do this before I started the video. Here's our table of torture here. Okay, so I have the connection spot in here for picking up the AVC voltage and delivering it to this meter over here. Meter set for negative voltages cause it to go upscale. The ground is on the chassis. We're set to 15 volts there. And while I was doing this, the radio was sitting here on, and spontaneously the speaker dropped off the edge here. I had the speaker propped to let the air come out from it. And it just dropped off. It banged onto the bench, which caused me to jump. But at the same time, the radio went, just made this burst of hum, and then stopped. And then stopped humming. And I immediately turned it off. I haven't turned it on since. What's that all about? I don't know. Just sharing my observations with you. So hopefully what will happen now is with 437 still on the signal generator feeding into the radio, that should generate a signal at the detector, be rectified into a DC voltage. The DC voltage will show up on this meter. The stronger the signal, the bigger the voltage. That's the whole key to it. Then as I'm making adjustments, this meter will go up and down, showing when things are getting stronger and weaker. That's the whole idea. As long as this is on the correct frequency over here, which it isn't at the moment. Okay, let's turn the radio back on. And anything stupid happened. I don't know what that was. Could have just been a tug on the wire here or something. I don't know what the momentary hum was. That's twice I've heard this radio hum loudly. That was my stomach. Just in case you heard that sound. Not from the radio. Okay, up with the volume. Bingo. So the reason we can hear this tone is because I'm firing an inappropriate frequency, ramming it through the antenna system. It's not tuned to this frequency at all, but enough is getting through that it's coming out the detector, showing up on the meter here slightly. We have to prove that this is really showing the result here. So I'm going to just put my tripod like this, and what I'm going to do is I'm going to vary the first the strength of the signal coming to the radio. I'm just going to turn it down. There, you see the meter go, and turn it up. Whoa, whack it right off. Okay, that's fine. And now I'm going to vary the frequency and make this meter go as high as it can go, which is probably right where it is now. Yeah, so I'm putting it as high as it can go. This shows now the frequency it is tuned to. Once again, 437. Not right. Okay, so what we want to do now is set the signal generator to 455 and see if we still can't hear some of the tone. And to make it, I'll just turn this up higher and higher too. So we'll go to 455. Still hear it. crank this up. Okay, the signal is so loud that even though the radio is not really tuned to it, it can still hear it. Now I'm going to start tuning the transformers. And it doesn't matter what order really. So we're going to start right here. There's 4 adjustments I have to do. Okay, here we go. Now we're ready to adjust it. What are you looking at? Don't look at that stuff anymore. It's all about the meter down here. All about the meter. Let's try it like this. Watch the meter. Okay. Now, there's a second transformer. It's over here. We'll do the bottom of it while we're here. Okay, let me turn the signal down a bit. Okay, now I'm going to reach around the back of the radio and do the tops of these transformers. I didn't show this to you. I should have showed it to you. Oh my gosh. Okay, I'm in on one of them. Watching the meter now. So this is representative of well, it isn't. I was going to say of how strong the radio is getting, but that's not quite true. Okay, I turned it down on the signal generator. Watch again. There's the peak right there. Very good. One more can here. Okay, here we go. Every one of these. So this was tuned way off. My guess is somebody tuned it without instruments, but it could be just from age. Okay, so now we got the meter all the way up to the number 11 here. Now I'm going to do it all again because each side of the transformer affects the other a little bit. Come on, get in there. So it's basically a flathead, a flat screwdriver type arrangement here. There we go. Okay, watching the meter now. We got a little more. This is also if the misalignment initially is kind of like that, which appears to be the case, then the response curve gets very wide, and that's what I sensed anyway when I was tuning the radio. As I do this response curve is getting sharper and sharper, and the radio will be able to select out stations better and better and not hear the adjacent ones. That's the idea of it. So I can do this one down here again. Got a little tiny bit there. Okay, just checking my signal generator frequency. It's correct. Just in case it had drifted off in some way. Okay, we're in this one now. Watching the meter again. Just the tiniest little bit there. And the last one. No use going around again after this. In we go. Okay, and really nothing much to gain on this one. Okay. So that would appear to have been significant. That would appear to have been a significant improvement. So now we're going to set the radio up just to listen and see if we can hear any differences that have occurred. What do I need? It's not hard to do that. So we're going to take it off the signal generator here. Wow. That's pretty sensitive radio. This is the antenna. I'm holding the entire antenna right now. Okay, we're going to clip it in over here. And we'll tune around. So I'm tuning through it slowly. Just this AVC is still valid. This will still show the signal strength. So it sounds like this to me, nice and smooth. Still got that. What is that? I don't know if it's this radio or not, but way up at the high end. Let's go back down.
Break down internal trade barriers by Canada Day. But the time left on the parliamentary calendar suggests the legislation will not gain royal assent by the time the House rises for the summer. Well, the first full weekend of June.
Hey, what happened there? The tone's not doing anything.
The best day to get outside was sun, cloud, and a high of 25 expected. Perfect for this year.
Jimmy, did you hook the tone capacitor up or on? I wonder. Okay, so radio's operating, everything's okay. I know the IF now is properly tuned. That sets us up to do the rest of the alignment, because the rest of the alignment is dependent upon the dial position. The dial is stuck back here in the radio. It's down here in the radio. It's not up there. So what they've provided with this radio, I'm just going to jam my camera over here. You can see on the back of the big wheel, this thing here, right in here, there's a scale. Okay, with numbers on it. Now that's in degrees, actually. I think it is in degrees. And if you look at the chart here, you'll see that they are giving a degree amount right here. 30 degrees, 151 degrees, 106 degrees. They're referring to the chart on the back of that dial. That's what we're going to rely on to do the rest of the alignment work. And I think that's probably, oh yeah, I just want to check this one capacitor. Did I boob it up? What happened to the tone? Ooh, that might explain things. Let me look.
28 bi-weekly with 5,000 down plus PDI, admin, and tax.
Rent a car for $1,000 a month. Maserati. I gotta do better on the YouTube channel before I can rent a Maserati. Okay, on the diagram up there, you can see the tone control capacitor right here. You see it says 0.005. Now I stuck in a 0.05. I stuck in a 10 times too big capacitor. That's probably why the radio is not very loud. Okay, so I'm going to change this capacitor to the appropriate one. You leave the volume and everything just as it is. I won't touch it. We'll change the capacitor, turn it back on, and we'll find out if it's louder, because that was not very loud there. Turns out I'm wrong. This is a 0.005 capacitor. So why no tone activity anymore? Something wrong with this capacitor? I don't know. I'm going to take it out of there. I tried testing it while it's in the circuit, and you know, you really got to kind of doubt whatever result you get when you do that. So I'm just going to disconnect it from here. Now it's a brand new capacitor. It's not in any way old. So it should test like a new capacitor. So it says it's a almost 5,000 picofarad. 5,000 picofarads would be 5 nanofarads, 0.005. That's correct. Nothing wrong with it. What happened? How can this stop working? How can the tone control fail to work? Well, that's not exactly the easiest. Like the other wire, it's just going to ground. So all you're doing is grounding some of the signal through a capacitor, and the idea is the capacitor lets the treble through to the ground, so you rob the signal of the treble part. That's called a treble cut. And it's just a really basic tone control. You don't get any more basic than this. How could it be that this wouldn't work? The other connection looks great. Like it's just a. It's supposed to go. Looking at the schematic here, which might be a little small. It's supposed to go. Where did you go? So off the tone control end, straight to the plate wire, which should have a resistor on it and a couple capacitors, but they could be distributed. Goes to the plate of the 6F5. Let me just double check that and bring about certainty here. Where's my book? 6F5. I could do this otherwise, but I'm going to do it like this. 6F5. Not much to it. The plate is pin number 4. That's where this capacitor should be connected. Pin number 4, eh? Number 4. One, two, three, 4. So a couple of these are tied together. I'm studying the solder very carefully. I don't see anything at all that could anyway herald a problem. Where did the tone control go? I'm just going to reheat these connections on account I don't know what else to do. And I just can't see how this is not connecting. Well, that might just end up being a mystery. Okay. Other than that situation, which I thought I was going to solve right away with changing the size of that capacitor, but no, I don't know why the tone would stop operating. Why would the tone? Because the control doesn't work anymore? That doesn't make a lot of sense. Possible. It's lost its contact. That would be a come and go thing, you know. But, $25,000. Okay, I think it should be down to 0 now or close. Down to almost 0. Up to its maximum. I don't know how big this is. There we go, 1.2, around 1 megohm. It could be I'm at the end of the run here. Things get a little shaky in these controls when you get right to the end, so I'll just turn it back a little bit. Let's see if we... So 700. So I mean, it makes sense. It's probably a 1 meg. Well, I've got it right on the thing here. 1 meg tone control. It says right on it. I don't know how to explain that. So we're going to just ignore it for now. I should test the radio one more time because I did desolder and resolder those things. So let's do that. Boy, I really thought I'd hit it because I put too big a capacitor in the tone control and it's going to just snuff the sound out, all of it. Like, it would be very, very muffled. And it wasn't very, very muffled. It's just quiet.
Hoverbridge Street. Construction. We found EVP. Approaching Shepherd to Seth of Lawrence as they get into the long-term construction.
I don't get it.
Garner,
Oops, you're too far there.
approaching Spadina now, west of Jarvis. If you're joining from Jarvis, you get it a little bit of a break, and then it slows again all the way through to approaching Jameson, thanks to the long-term construction. And KBW West delays 4 Drive to Trafalgar. Southbound 410 construction on the ring.
Oh well, might as well turn it off. I think I'm done for today. Tomorrow we're going to get into much more difficult alignment things. Doing the alignment can sometimes reveal more problems, aside from discovering the tone control situation. And so it still is kind of a preliminary process in the sense that I'm bound to realign the radio again a little further down the road. But we will attend to that tomorrow. It'll take the whole session to do it tomorrow, I'm pretty sure. Okay, well, thanks a lot for watching. Bit by bit, I don't know what's happening. Have a great day. See ya. He hasn't forgotten about the microphones from yesterday. No. No. Do you understand what I'm telling you? I'm telling you no. Do not eat the microphone. Oh my gosh, come on. Yeah, welcome to my shop, all right. So at some point I actually fix radios here, or try anyway. Oh my gosh. Okay. No, don't go after the microphone again. Oh my god. Come on, look. Okay, you know what? You gotta come down. And I'm afraid I gotta kick you out of here. Say goodbye to the nice people. Goodbye. You're going out the door.